So I'm going to start with looking at 8.1 part 2. Okay, just a reminder about what the law of signs is. So remember, it's 3 fractions. And you only use how many fractions at a time? Yeah, only 2. First 2, last 2, or the first one and the last one. And every problem with law of signs basically comes down to a proportion that you have to solve. How do you solve a proportion? Yeah. Yep, cross multiply. Now, there's 3 types of problems that we can use law of signs on. Does anybody remember we use the letters like A and S, those letters? Does anybody remember one type of problem that you can use law of signs on? Yep.
Side angle.
Yep, side angle. And that's the one that we're going to focus on more today because there's 3 things that can happen, and we'll talk about that in a second. How about another type? Yep.
Angle, side angle.
Yep. Angle, side angle, or a variation of that type, just different placement of information.
I was going to say side and side.
No, we'll talk about that one now. That's going to be tomorrow. Yeah. Anyone know? Yeah.
Side angle, angle.
Side angle, angle. Yes. All 3 of those you can use law of signs for. Okay. The second 2 types always have one solution. There's 3 things that can happen here. Does anybody remember the 3 things that can happen when you're solving side angle? Only one of them was on the last test. You will see both of them on this test, though. Yeah.
You can have 1 solution, 2, or none.
Right. So you can solve a problem and end up with no solution, 1 solution, or 2 solutions. And does anybody remember the case that we did on the test last week? It's the one I went over in class. Yep. We went over the 1 solution. So we talked about the second solution, but we realized it didn't work. Okay, today, it will work. Right. So we're going to talk about the 2 solution, and we'll do the no solution, and there's going to be a couple word problems. Word problems are generally 1 solution. Because if you think about, like if you were looking at a map, right, we're trying to measure the distance between 2 points on a map, well, there's only 1 solution to the actual distance. So we'll do some word problem practice with 1 solution.
For the 2 thing, you're talking about the ASTC chart thing, and then what the 180 minus, the 180 plus, the 360 minus, like that's what you mean by the multiple solutions?
Yeah, so we'll talk about that ASTC, but remember, since we're dealing with triangles, what's the biggest that an angle can be in a triangle? Yeah.
It can only be 180.
Can only go up to 180, which means we only ever have to worry about things there. T and C are impossible in triangle problems because you can't have angles bigger than 180. So when we're looking for a second answer to a problem, that's where the second answer always is, where sine is positive. And the other reason it's always here is because we're studying law of sines, and that's where sine is positive. Can't have negative lengths in a triangle, so negatives wouldn't make sense.
But we do use the TNC when we're doing the complete the square thing, where it's like tangent times like cosine or something. Then we do that to find the multiple solutions.
We have used them in like section 7. What was it? 7.6.
But yeah, the complete the thing where you have 2 parentheses and the 2 different like trig,
Factor.
Yeah, trig.
Yeah.
2 different trig factors.
Yep.
Yeah, I just want to make sure I'm following.
Yeah. What else about law of sines? I was just trying to think. Okay, so here's the information they're giving us. I would make these boxes that you're going to write information in plenty big enough. And one way you can determine its law of sines without a picture is just by looking at the table. what has to happen in the table if it's going to be a law of science problem? Anybody remember? Yeah?
It has to be at least one.
Yeah, you have to have one row that's complete. That's why when you have a side problem or a side angle side, you don't have a complete row. That's why those two types we're going to learn tomorrow. And that's the law of cosines. Yeah, but this is definitely law of science. So really, you can figure this out without a diagram. All right, we are forced to find something first. What's the first thing you have to find? And you don't have any way around this. Yeah. B we know. Beta we don't. So yeah, you got to do beta first. So you're going to do that box first. What box is going to be second? Yeah.
Gamma.
Yeah, then you got to do the gamma box second. And then you can do anything in the C box third. Whether there's going to be one number in each of these boxes, two numbers, or no number, well, that's what we have to start to figure out. But you don't have to worry about the stuff that was given. A, B, and alpha, those are done. Okay? We just have to worry about what we don't know.
Technically, you could do C first, right?
No,
How?
Pythagorean theorem.
no, that only works if we have one angle that's 90 degrees, but we don't have one that's
Correct.
90 degrees.
Yeah, if you use Pythagorean theorem, you're assuming this is already a 90,
Oh yeah, okay.
and it probably won't be.
I don't know.
Well,
I don't know.
I guarantee it won't be.
You're assuming that either B or C is a 90. Either beta or gamma is 90 degrees. It can't be.
So let's find beta. Let's find beta first, and we're going to set it up with law of science. Okay, so here's your proportion. Remember what goes in the top, sine goes in the top on both sides. And what could I fill in on the left side from that table? Yeah?
Sine 35 over 6.
Yeah, it doesn't really matter which side you put that on, but you got to have a sine 35 over 6 on one side. When you cross multiply, it'll all come out the same. So sine 35 over 6. And what's going to go on the right side?
Yeah. Sine beta over 8.
Sine beta over 8. Okay. And now we want to get sine beta by itself by doing what on both sides? Yep.
Multiply each side by 8, and you'll get 8 sine 35 degrees divided by 6, but that's not the last part that we have to worry about, because we've got to take sine out now.
Right, we got to get rid of the sine on the right side. And what gets rid of sine? Yeah?
Inverse sine.
Inverse sine. So what I'm going to do is I need a little bit more space, so there. Take inverse sine of everything on the left and on the right. When you do that on the right, inverse sine and regular sine are gone. And now we're going to type this in. If this is going to be a no solution, this number right here would have to be bigger than what or smaller than what? Because you can only take the inverse sine if the value here is between certain numbers. So if it's above this or below this, you're going to get no solution. Yeah?
Above 0 and smaller than 1.
No, not that would partially be a solution. That would be a solution. But what wouldn't be if it's above 1? Yeah?
Above 1.
Above 1.
Well, you can't do the sign of the negative?
You can do inverse sine of negative numbers, some negative numbers. Yeah? Right. So this can't be above 1 or smaller than negative 1. If it is, you'll get no solution. Okay, I'm pretty sure this comes out between negative 1 and 1, so it will work. Okay, so first, make sure you're in degrees.
When it's in degrees, it'll be something else for what it needs to be between, I'm pretty sure.
Still has to be between -1 and 1. Any inverse sign has to be between -1 and 1 for the domain. The range will change now that I'm in degrees. Okay, the range will be between -90 and 90. And I can guarantee, since we're doing a triangle, it's not going to be negative. So I can tell you the range will be between 0 and 90.
If one of your angles has no solution, like if it came out and it was just an error, is your triangle just not solvable?
Right. Once you get a no solution, you're done.
Okay.
You can't do anything. So make sure you type that in right with parentheses. Close the 35, and then close it for the 6.
When you get it, it's going to be 49.89.
Yeah, and we're gonna go to 3. So we're gonna do 0.886. So this problem has a solution. That's one right there. Okay, so 49.886. Now you can double check this, but you're taking the sine of 35 times 8 and dividing by 6. This number. Okay. First of all, sine of 35, what quadrant is 35 in?
Quadrant 1.
Quadrant 1. And what is the value, if you take the sine of something in quadrant 1, what kind of answer do you get?
Positive.
Positive. How about if you multiply that by 8?
Negative.
A positive number times 8 is a negative?
Positive.
Positive. And what if you divide that by 6?
It would still be
Still be positive. So the point here is you are taking the inverse sign of a positive number. Think about where sine is positive. Quadrant 1, which we just got, 49.886, and quadrant 2. What's the formula in quadrant 2 that we're going to do with the 49.886? Yeah. 180 minus. So we're going to do 180 minus the last answer that we got. Now I'm not going to write that down yet because I got to see if that answer fits. Okay, it's 130.116.
It fits.
What angle were we given to start from? Yeah.
We're given 35 degrees.
Right, we were given the 35. So we know that the 35 is in the triangle. Can you fit a 35 and a 130 degree angle in the same triangle?
Yes.
Yes. So that means this second answer is going to work. It does not add up to more than 180 with the one you started with. If this second answer was like 160, then I would say no, it doesn't work. Because 160 plus 35 is too much. But this time it fits.
If the first angle you get is less than the first angle that you have, then you can stop right there.
Yeah, that would probably tell you it's not going to fit. Yeah.
But if it's bigger, it will fit.
So now what we're going to do is instead of just having one answer for beta, we're going to have two answers for beta. Okay, so we're going to have a beta 1 and we're going to have a beta 2.
It's
Beta 2 is what was on the board right there.
130.114.
130.114. Now, once you know that there are two answers for beta, or two answers for whatever angle you solved for first, everything has two answers now. Okay, not the stuff that was given. That's done. Just the stuff that you don't know yet. So that's going to have two answers. And that's going to have two answers. So if you want to think about it, like if I can kind of color code it and just show you what we're doing. So let's start with what we call the blue triangle. The blue triangle has alpha in it, beta 1, and gamma 1. Those are the three angles in the blue problem. In the green problem, we've got alpha, beta 2, and gamma 2. Those are the three angles in the green problem. So alpha is shared. It's in both problems. And then same thing for the sides. A was given, so it's in the blue problem. B was given, so it's also in the blue problem. And C1 is part of the blue problem. So the 6 dots you see in blue, those are the three sides and three angles in that problem. And then A is in the green one, B is the green one, and C2 is the green one. So what we're doing, we're solving two problems at the same time. We're just using the same table to do it because these three things are in both problems. The A, the B, and the alpha. Right. So now, how would we get gamma 1? Yeah.
We would subtract the alpha and the beta combined from 180.
Can you be more specific?
180 subtracted by 35 plus, in parentheses for the 35, and the next one, 49.886.
Yep, that's what I was looking for. So the beta 1. So the alpha plus beta 1, subtract that from 180. All right, so we can do that all in one step.
It's going to be 95.114.
Yep, 95.114. So that's gamma 1. Now, you do have enough information. You could go and do C1 now. But what I like to do is let's just finish the angles off first, and then we'll finish all the sides off. Can someone else tell me how I'm going to get gamma 2? Yeah? Yeah. So we're going to take 180 again, and we're going to subtract the 35, but we're not using the 49.886. We're using the 130.114. And we get 14.886. Any question on how we got gamma 2? Now, we just have to finish up by finding the last side in the blue problem and the green problem. Okay. So let's do C1 first. Okay, C1 is part of the blue problem. So what we need to start with is a row that's in the blue problem that has everything in it. What row could we use that's in the blue problem? Makes it kind of hard to see with the highlighting. Makes it look darker. Yep.
You'd want to use the top row, which is A and alpha.
Yes. You want to use the top row.
Because we have those as certain numbers. We have those again.
So we're going to find C1. Set up a proportion. And it's going to look exactly like the proportion we started out with. Okay, sine 35 over 6. So 35 over 6. And what's going to go on the other side to find C1? Yep.
Sine 95.114 over C.
Sine 95.114 over C1. And let's set up C2. Since it's going to be almost the same. Sine 35 over 6. And what's the angle that's across from, what's gamma 2? Yep. 14.886. Okay, so let's write our answer. C1 and C2. Okay, what is C1 going to be? Okay, you don't have to give me the decimal, just kind of like what times what divided by what. Yeah.
Would it be oh wait, I'm drawing a blank. Shoot. Okay, cross multiply.
Yep.
So you would have 6 sine 35 over sine 35.
Okay, so we'll type that in, see what we get. And now on the other one, it's going to be the same same setup. 6 sine in the top, sine 35 in the bottom. But instead of the angle of 95, we're using the 14.
I've got both of the answers right here.
Okay, what does C1 come out to?
C1 comes out to 10.419,
Okay,
and C2 comes out to 2.687. 687.
6, 8, 7. Okay. That's it. There's your two triangles. So that would, each answer here would count as its own answer. That'd be 6 different answers. So that'd probably be worth quite a few points. So any question on the 2 solution?
Kind of weird question, but is there a special way if it's on the test will it ever ask us to like show the image of the triangle, and if it does, are we supposed, is there a special way to show the 2 overlaid or the 2 separate if that exists?
No, you don't have to draw them.
Okay.
No.
Thank you.
No. I'm going to show you what it looks like when you draw them. Just using this example right here. So I'm not going to do any numbers on this. I'm just going to show you how I can take 2 sides and an angle that's not between them and copy them to a different triangle, or copy them to another triangle that looks different than this. So the first thing I'm going to do is I'm going to take this side, I'm going to copy it, I'm going to zoom out, I'm going to put that right there. Okay. Does everyone agree that that side and that side are the same?
Yes.
Okay, so I've got a side that's the same in both. Okay, next thing I'm going to do is I'm going to take this triangle, I'm going to copy it, but I'm going to reflect it. Is the side that's on the right the same as the length? Is the length the same as the one up above? Yeah, just a reflection. So now I have a different triangle with 2 sides the same. And now I'm going to draw the bottom side. There we go. And does everyone agree that the third side on the bottom here is exactly the same as the third side on the bottom there?
No, it wouldn't be.
Okay, good. Because they're not. But if I group them all together, so I can move them easy, you can see there is an angle that is the same in both of them. Does anybody see which angle?
That's bottom left.
Yeah, the bottom left angle is exactly the same in both. So here is my angle. That's the same. So I took 2 sides and an angle from one triangle, duplicated them in a different triangle, and they are not the same at all. Okay, not the same. That's the only case you can get 2 answers on it. Okay, any question on that? Yeah?
So the 2 sides are equal, the angle is equal. But what does that prove?
it's showing you that if I ask you to draw a triangle with two sides and an angle congruent, you can potentially draw two different triangles some of the time.
Okay.
You can't do that with, for example, side, side, side. That's impossible. If I tell you to draw a triangle that has a side length of 3, 4, and 5, everyone's would look exactly the same. You can't draw two different triangles that have all the same sides. That doesn't work. But two sides and an angle, you can.
You can also draw two triangles to have the same angles, but they would have completely different sides from each other.
Yeah, so angle, angle, angle isn't one that we study because we can't do anything with angle, angle, angle. If I just told you all the angles are 60 and I said tell me the length of each side, you can't. So that's not one that's solvable. Yeah?
I have a weird question again, but for the whole multiple triangles thing, would there ever be cases even in like higher math where you have like a plus or have the square root thing, and you have the plus or minus value, and so then you can calculate multiple triangles from like the plus or minus value? Is that possible even in higher math with the triangles?
I'm not sure what you mean by the plus or minus
So,
value. Like quadratic formula, plus or minus?
Yeah. So basically, when you solve quadratic formula, you end up with an answer that's plus or minus, and then you have multiple solve for zero things. So, because I know that's one way to get multiple things. So can you potentially apply that to the triangle where each side is a plus or minus value, and therefore you have like multiple more than two solutions, or is that?
I've never heard of more than two.
Okay.
This is called the ambiguous case because three different things can happen. The only things that I know of in the ambiguous case are no solution, one solution, two solution.
Okay.
That's it.
Thank you.
Yep. All right, so we know that this is going to be law of sines because you got a full row. And we also have a row that's empty. That's how you know it's the worst, right? Side, angle. All right, so what do we have to try to find first? There's no traces here. Yeah.
Alpha.
Yeah, I'm going to find alpha first. All right, so let's set it up. So sine equals sine. And what could I put on the left side? Yep.
50 degrees in
So sine 50 over 1. So that's not even really a fraction, just over 1. I mean, it is a fraction, but cross multiplying is going to be very simple with a 1. And then what would go on the other side? Yeah.
sine alpha over 2.
Sine alpha over 2. Okay, so all I'm going to do is multiply each side by 2. So you get 2 sine 50 equals sine alpha. And what do we do now? Take the inverse sine of 2 sine 50. Now, what does the number that you take the inverse sine of have to be between? It's got to be between, yeah?
Negative 1 and 1.
It's got to be between negative 1 and 1. So let's just see what 2 sine 50 is. 1.5. So now, what's going to happen when I try to take the inverse sine?
Error.
Right, we're going to get an error because you can't take the inverse sine of 1.5. So what that means is there is no solution for alpha. Okay, we can't find it. Now, what we would normally do at this point is we would subtract that angle from 180 to get beta. But since we don't know alpha, what does that mean about beta? We can't find that either, because you have no way to get alpha. And if you can't find an angle, then you definitely can't find the side that's across from it. Okay? So that's what happens in a no solution. They've given you information here that's physically impossible to make a triangle out of. Right? We're going to try to draw it. We're going to do it to scale. Measure it. I'll use a protractor to get exactly a 50-degree angle. and we'll see that it just doesn't work. Okay. All right, let's try to draw it. So earlier I measured out, that is exactly a 50-degree angle. I used the protractor thing to measure that out. Does anybody want me to double check that to show you it's 50? Okay, so it's 50. Now, remember, when you make a triangle, doesn't matter, how you draw it, as long as you keep your sides and angles in the right spots. So if these two sides are A and B, the angle between them is gamma. Okay. All right, so let's, I need two sides. I need A and I need C. It doesn't matter what unit I use, as long as the relationship is right. A is twice as big as C. That's all you need. So if C is 1 unit, A is 2 units. All right, so let's let side C be this. Let's call that 1 unit. And for side A, how am I going to get something that's 2 units? And exactly to scale. Yeah.
Do C twice.
Yeah, just take 2 of the C's and put them together. All right, so take that. Take that. And, well, as close as I can get it. We'll group them. Okay. So, any questions or thoughts or disagreement that A is not twice as long as C? All right. Now, when you group something together, I get this little green handle that lets me rotate. I need to rotate, what side did I do? A is twice as long. Okay, yeah, I need to rotate A now so that it's at a 50-degree angle to the horizontal. So the easiest way to do that is just bring it over here and turn it until I get it exactly at 50 degrees, or pretty close. That's close enough. Now, I can't turn that. I have to keep it like that because any rotation I make is now going to mess up the 50-degree angle that I just set. Okay, so that's A. Now C is going to be over here somewhere. I can rotate this. In order to rotate it, though, I need that little green handle. So I don't know any other way to do it except to go like this. Group it with something. And now I can erase that. But since it was grouped with something, now I have the little green handle and I can turn it. You can turn this however you want. They didn't tell you what this angle up here had to be. Okay, but what you can't do is you cannot change the length of this one. You can't change the length of this one. And you can't rotate the one that's at a 50. So the only thing I can do right now is pretty much rotate that side, however I want. Now, the bottom side has to stay as a horizontal. If it's not a horizontal, I'm going to mess up the 50. So I have to keep that horizontal, but I can make it as long or as short as I want. So the only two things you can change are the length of the bottom and the rotation of that side. If I change those, will they come together to make a triangle? No. No matter how I do it, I can never make a triangle. What's one thing that could happen that would allow these sides to connect? What's one thing you could be allowed to, if you were allowed to do it, you could make them connect? Yeah?
Or change the size of C.
Change the size of
The length.
C. Yep. So C is the short side. If you could make it longer, yeah, you could make them connect. Or what else could you do? What if I said you can't change the size of C? Yeah?
You could shrink A.
You could shrink A.
The length.
Yeah. If you made the length of A shorter, eventually it would connect.
Or the angle.
Or you could change the angle, right? If you were allowed to make this angle maybe like a 30-degree angle instead of a 50, that might connect. So if you could change any of those things, you could make it work. And kind of a little bit higher level problem than what we're doing would now be to say, okay, you can't change the length of any of these. Tell me the biggest that this angle can be, and this third side will still connect. If I go any bigger, it won't connect. So I would want to know exactly the size of that angle to make that side connect. The biggest it could be. Is it 30, 31.6? You have to think about how to figure that out a little bit.
Do you mean like?
Not something I'm going to get into right now.
Yeah, but you don't mean like treating it as a right angle, like, because then you could just kind of treat it like. How, like, what level of math is that?
It's pre-calculus. Yeah, it's pre-calc.
It's still pre-calc?
Yeah, oh yeah. You don't need calculus or anything to figure it out.
Oh.
You can do it with just trig and algebra. You could figure out what that would have to be. Yep. It's just a little bit more of a thinking problem than the kind that we've done so far. All right, so let's take a look at this. So this one is going to be a word problem. So the first thing we're going to have to do with the word problem is we're going to have to figure out how do we represent everything they're giving us. So what we're going to do is we're going to measure the height of a mountain. Now, what I'm describing here, this actually works. You can do this. And the idea is you're going to measure the height of something by standing in one spot, measuring something, and then backing up a certain amount in a straight line, and then measuring that same thing again. Okay, so you have to measure something from two different spots. And this particular surveyor is going to measure the peak of the mountain. I'll tell you what about the peak in a second. But they're going to measure something that goes to the peak of the mountain, and they're going to do it from a distance of 900 meters apart. Okay. That number would be easy to figure out. Okay, if you just stand in one spot, and then you get in your car, and like if let's say you're in the middle of the desert, that'd be the easiest place, because then you could drive in any direction without an issue, usually. And then just back up 900 meters from where you are. Okay. And then you're going to measure again. What you're going to measure each time is what's called the angle of elevation. Okay, the angle of elevation is if you're standing, basically you want it to point like a laser, at a target. What angle would you have to tilt the laser at so it's pointing at your target? And it's the angle of elevation, which means it's the angle with the ground. So if you had a laser on the ground and you started tilting it, if you pointed at 47-degree angle, it would be pointed right at the peak of the mountain. Now, if you back up 900 meters, what's going to happen to the angle? Yeah, it's going to decrease. Right? The further you back up from a target, the less steep of an angle you have to put, assuming what you're pointing at is staying still, and the mountain is staying still. So the second observation gives you an angle of 35 degrees. Now, there is a different kind of angle that is used as a reference sometime, and that's called the angle of depression. An angle of depression would be like if you were in an airplane and you were trying to point, let's say, or a helicopter, because that can stay still. So you're in a helicopter, and you want to point a laser down at a target. The angle of depression would be if, like, you draw a horizontal line through the helicopter and you start angling the laser down. That's the angle that it makes with the horizontal that the helicopter is at. Okay. So you just have to look at the problem and see, is it about angle of elevation or angle of depression? Depression is down towards a target. Elevation is up towards a target. Now, the device that they would use to figure this out, it could be a transit. If you've ever seen like people on the side of the road, like they got a tripod set up And then a little further down the road, they have another tripod. That's a transit. And what they're doing is they're measuring something. It could be measuring property boundaries. It could be measuring the road. Make sure it has like a grade to it for water runoff or whatever they're measuring. Okay, that's a transit. Now, normally a transit is not right on the ground. Like it's on a tripod, and then the person's looking through something. So the transit is like 5 or 6 feet off the ground. But we're going to assume that the transit is on the ground, like the actual like laser is like right on the ground. Otherwise, we just have to take into account the height of the laser off the tripod. But I don't want to get into that. Okay, so we got a lot of information. What do you think we need to do with all that information? We need to turn it into something. What do you think we want to generate from all that? Yeah? Okay, we are going to use law of signs problem, but even before we get to the point where we're thinking about an equation, I want to take all of this and turn it into a...
Could you do it into like that mini chart where it's like A, B, C, and then alpha, beta?
You could make a chart.
Really plug in and then you...
Yeah, you could make a chart to organize everything, but even before that step, what do you think we want to do with all of this? Yeah?
Well, you can draw a diagram.
Yeah, we want to draw it all out. So don't worry about like saying, well, there needs to be a triangle in the picture. Don't worry about like math stuff. Just worry about the objects in that problem, and then triangles will happen automatically. So what's one important thing that needs to be in our diagram? Yeah?
The two signs of the peaks 900 meters apart.
The two sightings. Okay, we do need to mark the two sightings 900 meters apart. I need some more stuff in my diagram before I can put those on it.
Like the observer and the objects first?
Okay, what kind of objects do we need?
It's like a research team, so you can just do like a circle, but the objects being looked at are like, it's looking at different mountains or the same mountain.
Same mountain.
Okay,
One
so
mountain.
they're gonna do one triangle and then two circles on different distance apart.
Okay, I need something else too. This is a very fundamental thing for this picture. Yeah, I need the ground. Right, the mountain has to be on something. So, let me actually draw this nice straight line. Okay, so there's the ground. And we've got our, mountain. There's our mountain. And we know that they're looking at the peak of the mountain. And how many different spots do they measure the angle to the peak from? Two. So let's say they do it from that spot and that spot. What do we know about those two spots? Yeah? They're 900 meters apart. Now what I'm going to do is I'm going to put in a dotted line, and that's going to represent a laser going right to the peak of the mountain. So we got one right about there, and we got another one right there. If your object is moving, this method doesn't work as well, unless you have two people that can see the object at exactly the same time. But if you have to drive 900 meters away and your object moves in that time, well, no good. Okay, what else do we know? Yeah?
We know the two angles.
Yeah.
Which are 47, 35.
Yeah, so the first angle is the angle of elevation from the ground. And the second time it decreased to, what was it, 35. Okay, and what are we, did it say what we're trying to find? The height of the mountain, to measure the height of the mountain. So what's the height of the mountain? Is it, like if you had a pyramid, is it like this? Is that the height of the mountain? Now that's the slant height of the mountain. What's the height? Yeah?
It's the distance from the ground to the peak.
Right, from the ground to the peak in a perpendicular way, almost like if you could drop something right down the middle of the mountain. If you were at the peak and it was open, you just dropped something, how far would it fall? And hit the ground. Okay, that's the height of the mountain. Okay, so here is the height of the mountain. That is what we want to find. So we've got a couple triangles in this picture. Let's start with this one. If we can work with this red triangle right away, that will tell us the height of the mountain. Let's put that down there. So you're solving for h, and you know that's 47, and you know that's 90. Okay, do you have enough information in this triangle to find h?
No.
No. What do you need to always have to solve a triangle? Right triangle or non-right triangle? You got to have at least one what?
Side.
You've got to have at least one side. So that red triangle is okay. We are going to work with it, but you got to figure out another side first. Okay. Does anybody see anything else we could label in this diagram? Because we got to label some other things so we can work with a different triangle first. Yeah?
There's like this thing where it's like, I heard exactly where it is, but the whole line equals 180. So if you subtract 47 from the 180, you get the inner angle.
Yep. So that's a straight angle or a linear pair. Depends how fancy you want to get with geometry. So we got 180 minus 47. And this angle is 133.
Then we can use that and set up the sine equation for the middle, like the slant, and then we can use that for the.
Yeah, so we can focus on this triangle now in green. And the reason that's a good one to focus on is because it has something in common with the red one. They share a side. So if you can figure out the length of the side in the green one, that's the hypotenuse of the red one, then you're all set. Okay, so let's copy the green one down and start filling in what we know. We know the bottom side is 900. We know the angle in the lower left is 35. The angle, the obtuse angle is 133.
12 degrees is the third angle.
Right. The problem is to use law of sines. The whole trick is you need to know an angle and you need to know the side across from it. Well, we can get this angle because we know the other two. Plus 133 and 35 adds up to 168, which gives you a difference of 12 from 180. Yeah.
I missed how you could found 35. I didn't know that.
The 35?
Yeah.
That was the angle of elevation that was observed.
Also, it was a given. Okay.
That was good. Okay, so now let's call this side C. What would be my law of sines to find C? Yep.
Sine 35 over C,
Sine 35 over C, yep,
and then sine 12 over 900.
equals sine 12 over 900. This was the whole key to the problem, the 12 and the 900. Okay, I'll leave that part for you. Okay, so now you could find C. And then once you find C, that's this side right there. So now you know C. How can you find H? Somehow using the 47 degrees and the C. Yep, what trig function would you use?
Couldn't you do the same? Because I mean, sine.
Well, you could do law of sines again, but this is a right triangle, so we don't have to make it that complicated now. We could use Sakatoa to finish that off. what trig function would you use? Sine, cosine, or tangent?
Sine, because hypotenuse over C is so.
Opposite over hypotenuse. And what would that be when you set that up?
Sine 47 equals C over H, which
That's cosecant.
H over C.
H over C.
also over. Oh yeah.
Yeah, just H just stands for height in this problem, not hypotenuse. It is a tricky letter to use.
Yeah.
So opposite over hypotenuse.
And then here you know C, so you can do.
So what's the height?
So you do C sine 47.
There you go. There's your height. And you know C because you would have just figured it out from the last part.
And you can plug into the calculator until it's cool.
Yep. That's it. I think the hardest part there is just figuring out what two triangles do you need to use because you can't find what they want you to find right away. All right, any questions on that one? Okay, so last word problem. This one is going to be about a boat, let's say in the middle of the ocean, and two Coast Guard stations can see the boat at the same time. So you don't have one observer that's now going to drive 900 feet back or whatever. You just have two Coast Guard stations seeing it at the same time. Now, we're going to assume that the boat, maybe it's at night, it's cloudy, and the boat still has their engine, but since it's cloudy and foggy, they can't use the stars to figure out where they're at. It's foggy, so maybe they just want to be careful what direction they head in. So they're going to try to get help from the Coast Guard tower. So let's assume that the boat is easy to see. So maybe they have a huge light on the boat. And the Coast Guard, if they use binoculars, they can just barely see a light, way in the distance. And that's how they're going to find where this boat is. Okay, the two Coast Guard stations are each going to see that speck of light in the distance, and they're going to work together to figure out where the boat is. Okay, so the two Coast Guard stations are Zulu and X-Ray, and they are 120 miles apart. That's taking the place of our 900 meters. Okay, that's how far apart the two Coast Guard stations are. Now, in general, the Coast Guard stations are usually on the water. They're on the coast. Okay, so they're going to be right on land, but the boundary to the water is going to be right in front of them. Okay, so the ship turns on a light, sends out an SOS, and each Coast Guard station can see the light from the boat, but since the Coast Guard stations are in different spots, they see the light in different directions. It's kind of like, if you're, standing here or sitting there and looking at me, you have a certain angle that you have to look at to see me. Like some of you may have to turn your head to the right, but other of you, if I stand over here, you may have to turn your head to the left. So you just have a different angle you have to turn to see me. Same thing. So Station Zulu sees the light 40 degrees east of north. East of north is to the right. So if you got your compass, east of north would mean in this direction, like in a northeastern direction. Now the other station sees the same light west of north. So that means if they're looking north, they have to turn to the left, and that's where the light is for them, towards the northwest. So the question now is to figure out how far the ship is from each station, which basically triangulates the position of the boat. So that's what we're doing. We're triangulating the position of the boat. Now, slightly unrealistic, because chances are the boat would probably be drifting a little bit. If they didn't have an anchor, they might not be staying exactly in the same spot. So what they'd probably do is instead of having it exactly 40 degrees east of north, they'd probably put in like a margin of error. Maybe they might say between like 39.5 and 40.5. So it doesn't give them an exact spot, but it gives them an area to search. Okay. All right. So, like we did last time, what do you think we need to do with all that information? Yeah.
We need to set up a triangle. We're going to have...
Even before we think about setting up a triangle, that's going to kind of come as a secondary thing. But the primary thing is to make your diagram. Don't worry about where the triangle is going to be. Just draw everything. Draw the bearings, draw the boat, put the Coast Guard stations, and then just hope that the triangle pops out of it. Okay? All right. So what do we know about the boat? The boat is where? Yeah.
It's...
In very, very general terms, the boat is, yeah, it's in water. And the Coast Guard stations? On land. So we need a boundary line that separates water from land. We're going to pretend like we're looking at this from overhead. Okay, so we're like in outer space looking down at it. A simple boundary line. We're going to have 2 Coast Guard stations. One here. One there. And we have a boat out there somewhere. Okay. Now, what I want to do from each Coast Guard station, I want to draw in a line that represents north. Okay, so what I'm going to do is I'm going to go like that. And I'm going to go like that. So now we have a line that represents north. Okay. Which station is on the left? Zulu. So station Zulu is 120 miles west, which means left, of X-ray. So this is station Zulu, this is X-ray, and the distance between them is 120. All right. Now, the boat has a light. We'll say the light is right at the top. Each station sees that light. So let's draw a line of sight from the station right to the boat. Now we need some angles. Let's see. So the first one is 40 degrees east of north. And that's for station Zulu. Where is that 40 degrees going to go? It's 40 degrees east of north. Yep.
Is it in between the green and the green dot and the black dot in the...
Yep. So here's north. That's 40 degrees to the east. Now the next station, for them, it's 30 degrees west of north. So where's the 30 degrees going to go for them?
In between the dotted lines?
Yep, in between the 2 dotted lines. It's 30 degrees west of north. Yes?
From here, we're going to figure out what the inside ones are between the solid line and the dotted line, which is going to be extremely easy because we know that from north to east or northwest is going to be a perfect 90 degrees right there, meaning that the dotted line, in between the dotted line and the solid line on the left side is going to be 50 degrees.
Yep, that's going to have to be a 50.
And then for the other one, it's going to be 60 degrees.
It's going to be a 60. And anything else I can label in that triangle?
We can label the angle that's where the boat's at.
Yes, this is the whole key. We need this angle at the top.
We can figure it out using those other 2 ones, which is going to be 70 degrees.
70. Yep. Now, as I said before, realistically, they probably would have some kind of margin of error when they're looking at this boat. So you might have something a little bit more like this. Okay, so they have a margin of error from there, and then maybe a margin of error from there too. So if you zoom in, what you actually end up with, instead of an exact pinpoint where the boat is, you end up with more of a search area to look at. Okay, and depending on how big that area is, it could be pretty hard to find the boat in that area. But then it starts to get into all different kinds of search patterns, and how do you start exploring that area? Do you start at the inside and kind of spiral out? What's the best way to do it? And the Coast Guard has all kinds of methods they use to efficiently cover as large of an area as they can as fast as possible. It's pretty neat how they do it. They have a method. I forget the name of it, but I watched it once. Okay, but we're kind of simplifying this one so we have an exact spot we're looking for. And remember, we're finding this distance from the boat to each station. So let's call this side A and B. Okay, how do we set this up to find, let's do A first. Yep.
Sine of 120 over 70 equals sine.
Say that again.
Sine 70 over 120 equals sine 60 over A.
Sine 60 over A. 60 over A. All right, now let's find B.
Same thing on sine 70 over 120.
Yep, use that side again, 70 over 120.
And then sine 50 over C.
50 over
B.
50 over B. All right. So either one of these is enough information to triangulate where the boat is. Okay. As long as you know the direction you need to head and how far you need to head, then you can get to where the boat is. Maybe they're going to send boats from both locations at the same time to rescue them. So both of them need to know where they're going. All right. So it's cross multiply. I think it's Victor Sierra. I think that's the name of the search pattern. Victor Sierra. That's what they call it. All right, so 120 sine 60, and then divide by sine 70. So that's the distance from side A. I think that was Zulu to the boat. And side B is 120 sine 50. Divided by sine 70. Okay, so there's both your distances. So this is A and B. So I think again, A was Zulu to boat, and B was X-ray to boat. So now we know the distances. Any questions on that? All right, so that finishes up law of science. The two types of triangles we haven't done yet are side angle side, side side side, and we'll do those two tomorrow. Okay, so those are the problems for tonight. So it's page 435, 4, 9, 11, 13, 14, 18, and 19.